Right there, right. Let's have a quick look at this question. A particle of weight W lies on a rough surface of a plane which is inclined by angle alpha to the horizontal. Tan alpha is 4 over 3. Coefficient friction between the particle and the plane is that, a half. Horizontal force magnitude H is applied. A horizontal force of magnitude H is applied to P. This force acts vertical to the plane through a line through the greatest slope. It is given that H is greatest value for P remains in equilibrium. Okay, so let's just quickly, there's the horizontal, there's the slope. Let's keep that slope going. This slope is on alpha. Now let me just quickly set alpha up. So basically we got indicate diagram forces. We'll do that in a second. So we got if I draw a quick diagram here and put alpha there, you got 4 over 3 opposite over 3, and that's the typical Pythagorean triangle, so that must be 5. So you got sine alpha equals 4 opposite over hypotenuse, and you got cos of alpha equals adjacent over hypotenuse. Right, you got those two, and now you got P. Let's just say this is a P. So P, first of all, it's that goes, the weight just drops down like that, which is W. And if we go along here and set that along there, parallel to the slope, that is alpha there. So coming down, okay, coming down here is that's opposite, so that's going to be W sine alpha. Now it's saying that, I'm going to put this in a different color. H is a force that's coming, a horizontal force of H is applied. So there's a force of H is applied on this particle P. Okay, and also it says friction. Now it does say that the force acts to the particle through a line to the greatest. It is given that H is the greatest value, so that's really exerting a lot on the verge of pushing it up. So if that's on the verge of maximum pushing it up, then we would have also friction. We'll go, we'll put an arrow coming down. Friction will also be coming down from here. Okay, so you got that. You got the weight on the slant, you got friction going down, so you got H pulling it, and I'm just going to put also one more force, which is from here to here. So put the arrow going up from here to here. This is called a contact force. So that is the contact force at P from there. Okay, so I've got all the forces I need acting on this particle P. So let's show that is the case. Okay, so let's have a look. So what we got, first of all, let's set this up. We've got forces going down. Now actually, because this H, if I go through there, this H is applying through there. Okay, so this H is we go that through the particle, go like that. Okay, so that's acting in line with that. And let's push that up. So this force going through is the same as 1 minute. So if I go through there, that's, we need that to be perpendicular. So we're just give me 1 second. So this force here, okay, and it goes through H, so that's going through here, and that's, we want the perpendicular forces acting on here. So this is H. Okay, so we want it parallel to this force what's coming here. So that here, before I start, that's going there. That angle here is alpha. Okay, because they are corresponding angles, and because that's parallel to that. H is parallel to the horizontal, so that will be alpha. So this goes force going that way, means it's going pushing the particle along that way. So another way of going is up here, up the slope and down here. So let me just draw that a bit bigger. So what we got here, got the H going there, and this is going perpendicular to that slope. So that's H going there. Another way is pushing that and pushing that down. That's the same effect. So that will push up here. So that's alpha. So along here, because that's adjacent, that will be H cos alpha along up here, and down here will be H sine alpha. Right, good. So that's going to be going up that way, and that is going down that way. So right, I'm ready to set my equation up to show this is the case. So what we got here is so first of all, let's make this force come down. So H is holding it up, so just put H cos alpha is pushing that upwards. So if that's pushing that upwards, what's going against it? We've got minus W sine alpha, and we got minus friction, which is going against it, and nothing else. So that's coming down, and that's coming up. That's good. So that's it, and it's held in equilibrium. So H is at its maximum, that will be 0. Okay, so we just need to find what friction is. Friction is going to be mu times R of P, the contact at P, what's going on. Now there's a couple of things happening at P. You've got the weight going down, you've got the H pushing it down, and then that's going to be the contact. So what's coming down? So R is going to equal to, so R of P is going to be equal to, so this is going to be equal to this coming down, which is going to be H, not H, sorry, this is going to be W cos alpha, and what else is going is H is coming down, so plus H sine alpha. So R is going to be reacting to that, so those two are, that's going up, that's coming down, and this is also coming down from this W, okay, from the weight. Okay, now we got that. Now before we start that, we know that mu here is a half, and we know these values, so I'm going to put friction, it's therefore going to be a half multiplied by RP, which is going to be W cos alpha is 3 over 5, and H sine alpha is going to be 4 over 5, and that's all going to be times by half. So I'm going to put it all in here. So that's going to be H, which is going to be H cos alpha is 3 over 5 minus W sine alpha is going to be 4 over 5, and friction is going to be half of that, so half times that's going to be so that's going to be 1 times 3 is 3, 2 times 5 is 10 W minus, and that becomes a minus half times that, so that's going to change into 2 over 5, that's going to be times by that, that's going to be H, that's going to all equal to 0. So let's just collect these. So you got 3/5, take away 2/5 is 1/5 H minus you got 4/5, which is 8/10, minus 3/10 is going to be minus 11/10 of W equals 0. So take that to the side, you get 1/5 of H is equal to 11 over 10 W, and if I times both by 5, you'll get H equals, now 5 times that will cancel the 10, so that'll be 11 over 2 W, which is what it wants. Okay.